There's a moment almost everyone has had. You walk into a room you've never been in, and for half a second you know it. Not remember it, know it. The light, the conversation, the exact angle of the chair in the corner, the way the air feels in that space. You've never been here, and yet some part of you insists you have. Most people call this a glitch, a misfire. Something briefly wrong with the machine. A crossed wire that shouldn't matter, that you shrug off and keep walking. But that's not what the research says. What if the strangest feeling in your own mind is actually proof that it's working exactly as it's supposed to? Not a malfunction, a signal. Let's find out what's really happening in the 2 or 3 seconds of déjà vu, and why the answer took over a century to find. The term comes from French, déjà vu, already seen. It was first written about academically by a French researcher named Émile Boirac back in 1876. For most of the century after that, nobody could study it properly. It comes without warning. It leaves just as fast. You can't schedule déjà vu. You can only wait for it. Somewhere between 60 and 70% of people report experiencing it at some point in their lives. It usually lasts a few seconds, and then it's gone. For a long time, scientists explained it using something called the dual processing theory. Your brain has 2 separate systems for recognizing something. One is familiarity, a fast, automatic sense that something feels known. No details, no context, just a feeling. The other is recollection, slower, more deliberate, actually retrieving the specific memory, the where, the when, the who. Normally, these 2 systems fire together almost instantly. Familiarity says, I know this. Recollection says, and here's why. Déjà vu is what happens when familiarity fires, and recollection doesn't catch up in time. You get the certainty, with none of the proof, like a verdict with no evidence submitted. But why does familiarity fire at all, if you've genuinely never been there? One leading theory is called Gestalt familiarity. It has nothing to do with the specific place. It's about the shape of the place, the layout, a window on the left, a doorway at the same angle as a room you walked through years ago and never thought about again. Your brain doesn't store that old room as a memory you can recall, but it stores the pattern of it, the geometry, the relationship between the objects, not the objects themselves. So when a new room happens to share that same geometry, your brain recognizes the shape without recognizing the place. In 2012, a psychologist named Anne Cleary at Colorado State University decided to test this directly. She used a video game called The Sims to build entire virtual environments, pairs of scenes that looked completely different on the surface, but shared the exact same spatial layout underneath. A doctor's waiting room built with the same geometry as an aquarium. A bowling alley laid out exactly like a subway station. Participants wore a headset, walked through one scene, and minutes later, walked through its geometric twin, dressed up as somewhere new. They had no idea the 2 spaces were related. But again and again, when they entered the matching layout, they reported déjà vu. On the spot, in a lab, on command. Some of the earliest evidence didn't come from healthy volunteers at all. It came from a Canadian neurosurgeon named Wilder Penfield. In the 1930s through the 1950s, Penfield operated on epilepsy patients while they remained fully awake, touching a small electrode directly to the surface of their temporal lobes. He was mapping the brain region by region, trying to find which areas were causing their seizures. But something unexpected happened. When he stimulated certain points, patients didn't just feel a tingle. They reported entire memories, sounds, smells, conversations they'd forgotten completely. And in some patients, stimulating that exact region produced the sensation of déjà vu, right there on the operating table, summoned by an electrode. For the first time, a feeling could be switched on from the outside. That region was the temporal lobe, specifically the hippocampus, and a neighboring structure called the rhinal cortex, the parts of the brain responsible for telling new from old. Decades later, patients with temporal lobe epilepsy confirmed the connection even further. For many of them, intense déjà vu is the very first sign that a seizure is about to happen, a warning seconds before the rest of it. Because doctors could watch exactly which regions were electrically active in that instant, déjà vu stopped being a philosophical mystery. It became a location on a map. Here's where it gets interesting. In 2016, a neuroscientist at the University of St. Andrews named Akira O'Connor figured out how to trigger déjà vu on command in ordinary healthy people without surgery, without epilepsy. His method was almost embarrassingly simple. Read someone a list of related words: bed, pillow, night, dream. Every word connected to one theme: sleep, but never saying the word sleep itself. Later ask if they'd heard any words starting with S. They'd say no. Then ask directly, did you hear the word sleep? Most people say yes. And the moment they say it, you can watch them catch themselves. They know it's impossible. They never heard it, but it feels completely familiar. That exact clash certainty, colliding with impossibility, is a small manufactured version of déjà vu. O'Connor could produce it in roughly 2 out of every 3 people he tested, reliable enough to put them in an MRI scanner and watch their brains while it happened. He expected memory retrieval regions to activate the hippocampus. They didn't. Instead, the regions that lit up were in the frontal lobe, areas associated with decision-making and conflict resolution. This changed the interpretation completely. It was your brain's memory-checking system catching a potential false memory before it happened and flagging it to your conscious mind. Not a malfunction, a save. The feeling of déjà vu might be the only time you consciously notice your own brain correcting itself in real time. This explains something that used to seem strange. Déjà vu is most common in people between 15 and 25, and it gets steadily rarer. The older you get, the obvious explanation is that aging brains get worse at this. But the checking system theory suggests the opposite. Younger brains have sharper, faster error detection. They catch more near misses, more small conflicts between what feels familiar and what actually happened. As that system quiets with age, you don't feel déjà vu because your brain got worse at protecting you from false memories. You feel it less because the checker itself is simply quieter now. Less vigilant, not less capable. There's a bigger idea hiding inside all of this. Most people assume memory works like a recording. You experience something. It gets stored intact, somewhere in your head. Later, you press play, and it comes back exactly as it happened. But that's not how it works. Every time you remember something, your brain isn't retrieving a finished file. It's rebuilding one from scratch. Every single time. From fragments, from patterns, from pieces scattered across different regions of your brain. Most of the time, this reconstruction happens so smoothly, so quickly, you never notice it's happening at all. Déjà vu is one of the only moments where that hidden process briefly surfaces. For 2 or 3 seconds, you get to watch your own memory system, caught in the act of building the very reality you're standing in. Déjà vu isn't the only version of this feeling. There's déjà vécu, already lived, a more intense version, sometimes reported by epilepsy patients, where not just the scene, but the entire sequence of events feels pre-lived seconds before they happen. There's déjà senti already felt, a purely emotional echo, with no visual trigger at all. Just the feeling, nothing to attach it to. And there's the exact opposite. Jamais vu, never seen. Staring at a word you've written 1,000 times, until the letters suddenly stop making sense. Your own name looked at too long, turning into strange shapes on a page. A room you've lived in for years, suddenly unfamiliar. Same system, running in reverse. Familiarity, failing to fire when it absolutely should. Your mind isn't glitching in either direction. It's constantly quietly checking its work. You only notice on the rare occasions it checks out loud. So the next time it happens, you're standing somewhere. And for half a second, the whole scene feels like something you've already lived. You don't have to reach for anything mystical. You're not glimpsing a parallel life. You're not remembering something that never happened. You're not broken, and you're not psychic. You're watching a very ordinary, very reliable system do exactly what it evolved to do over hundreds of thousands of years. Compare, check, Flag anything that doesn't add up. The unsettling part was never that something went wrong. From a Frenchman's notebook in 1876, to an electrode on an operating table, to a video game built to fool you, to a list of words about sleep, it all points to the same quiet fact. The unsettling part is how rarely you get to see the machinery at all. For 2 seconds the curtain lifts, and then it falls again. And you keep walking through a room your brain has already quietly confirmed is new.